Hello everyone, this is Taylor walking you through question 11 of the Spring 2019 MAS1 exam. You are given the following information. An annuity due is issued to a 30-year-old that will pay one each year until either she dies or reaches age 50, whichever comes first. Mortality follows the illustrative life table. Annual interest rate I equals 6%. Calculate the actuarial present value of this annuity. For this question, I've also thrown in the life table itself. So this would be found in your provided distribution and life table just paperwork that you're given during the exam. So I just have that copied here as it will appear during the exam. Also, this table is labeled the illustrative life table, where the interest rate is equal to 6%. So jumping into the solution, I cropped out a lot of the values so it's not as busy, but this is just subsetting rows, still showing everything. And then in blue I have highlighted what's actually used in the calculations here. Before getting into the calculations though, just a quick overview of what the table is showing. So the first and final column are just copies, and that's age. So you're a 0-year-old or a 5-year-old, it goes by units of 5 up until 20, and then starts increasing by values of 1, so 28, 29, 30, so on. The second column, I subscript x, this is really an arbitrary number, but you can think of it as there were 10 million people studied that were born, and then by the time everyone became 5, this is how many survived up to that point. So there are this many 5-year-olds of the original 10 million people. So this column is just saying how many people survived up to that age. Next is our death rate. So what this value is just the what would it be? So for this 1.39, that's just what number died. So that would be 9528 subtract 9515, these numbers, divided by the original amount for that year. So this is the death rate of 28-year-olds, what proportion of them died before they achieved an age of 29. And then they multiply it by an arbitrary 1,000. So if you had 1,000 people, how many would you expect to die during their 28th year? And it's 1.39. Next, for the annuity due, so this should be a double dot above the letter A. I couldn't figure out how to display that in my R Markdown file. But what this is representing is if you received $1 every year, and taking into account the probability of you living to certain ages based off of this column, what is your expected value? So if I am 28 and I die at 28, I assume I get $1, and it's not discounted at all because I got it that year, and so I would get 1. If I died when I was 29, I would get $1, and then I'd get another $1 that needs to be discounted 1 year. And I would multiply that by the probability that I die at the age of 29. And then if I'm 30, I would get $3, I would discount them accordingly, and then multiply them by the probability I die at exactly that age. So if you do that for all ages, that's what this quantity works out to be. It's the expected present value of all those payments. Next, this capital A, this is saying what is the expected present value of a payout. Expected present value of that, in this case, $1,000 payout upon death. So starting at whatever age you're at, I can either get $1,000 and it's worth $1,000, or I can live to be 29, and so I take that $1,000 and discount it back 1, and so on and so forth. So really you can think of it, you can, using the discount rate and this capital A, you can actually calculate this annuity due if you wanted to. But for this problem, we don't need this quantity. We're just going to end up using this column here. I looked into it a bit. I still actually don't know what this column means. So if someone wants to add that to the comment section of this video, I'd find that helpful, because I'm still not really sure what this squared term, what that corresponds to in this table. Now for the final section, all these e's, you can read that as being if you live n years, where n is the left number, so subscript 5, subscript 10, subscript 20. If you are alive that many years later, you'll get $1,000. What is the expected present value? So it's going to be a binary. If you're 28, if I survive to 38, I'm going to get $1,000. What's the expected present value of that type of system? So there's just those 3 different versions of that here. So now that we've walked through what all the columns minus the one I don't know means, to jump back to the problem, we have a 30-year-old, and we want to know what is the present value of this annuity that's going to pay until she dies or reaches age 50. Now, for this question, you just need to understand that the reason you can't just immediately use the life table with just one row is because we have this added condition of not including payments after the age of 50. So what we can do is break this problem up into 2 sections. One is, if we didn't have that age 50 component, that's a far simpler question. We can calculate that pretty easily, and that is just to say, what is the annuity due worth? And that's really just this 15.85. So scrolling back up to the table, we see if you got paid $1 at the beginning of each year, the expected present value of that is going to be $15.85. So that takes into account the probability of you dying at all the different ages, and what that expected payout will result in present value dollars, assuming you're currently age 30. So that's what we get here, and those are $1 payments. So if they were $2 payments, we would multiply by 2. You just multiply by whatever the payment amount is. So that's kind of a good starting point. And then what we can do is say, okay, so that's the payout for assuming you got paid until you died, full stop. Now we need to subtract off whatever proportion of that is related to payments after the age of 50. And so what you can do for that is kind of repeat the same process but for age 50 and discount it to present value dollars, because we care about when you were 30, not when you're 50. And then multiply that by the probability that you would have lived that long. So what I mean by that is, assuming you start at age 50, what is the present value of all those payments? So you get $1 when you're 50, you get another $1 when you're 51, so on and so forth. And then the expected payout of that, taking into account all the different ages you could die, is this $13. But that's the present value assuming you're starting at age 50. So what we can do is just take this quantity and discount it back to when you're age 30. And so to do that, we just take our interest rate, so 1 plus our interest rate, this 1.06, and put it to the negative power of 20. And so we can figure out what the factor is that we need to multiply this $13 by to get it in true present value dollars. So that's why we're doing this multiplication here. So now that we know this is how much of this expectation, this $15.85, how much of it corresponds to payments after age 50, the final step is we need to multiply that by the probability that you live past 50. Because in the event someone, this person dies when they're 35, it doesn't make sense to subtract anything off, right? Because they would have gotten all of those payments. So for that, we just go to this second column and look at the number of people. And what we can say is, well, of all of those who survive to be 30, of those people, what percent of them lived up to or past age 50? And that's just this simple calculation of 895,000 divided by 950,000. So that's the probability of living to 50 or beyond that, given that you made it to at least age 30. That's how we get this fraction here. Solving this all out, you get this 11.9591. But again, just to summarize, we have our annuity due value when we get payments of $1. This takes into account the probability of dying at all different ages, starting at age 30. But then we want to subtract off the present value of that same annuity, but starting at age 50, multiplied by the probability you live that long. And then that results in our final desired number, which is the expected present value of that form of payment system. So scrolling back up, we see that 11.95, that falls in the range of E, and so that's our final answer. Thank you for watching today's walkthrough video. Please consider liking and subscribing if you find these videos helpful. Thanks.